The second part of section 10.3 is where we're going to practice multiplying the radical expressions. So we've already done it where I've asked you to multiply square root of 2 times square root of 3. You know to multiply that. But what happens if I had an expression with an addition or subtraction sign in there and then there was a radical on the outside? Well, this can be looked at as if you had a number on the outside and an expression on the inside. So think of that in terms of the distributive property that we have done before, because that's exactly what you would do now. So I'm going to multiply square root of 10 times square root of 6. Now when I'm multiplying those, you have to think about what is alike. So since those both have radicals, I can multiply them and get the square root of 60 on that first term. On the next set, I had square root of 10 times 3. These are not alike because 3 does not have a radical, so I would not be able to multiply those, and so instead I would need to write it as 3 square roots of 10. Now at this point you would want to check to see if this would simplify so that you could possibly add those. So I would check that and see if I could break down 60. So I could see I could go 2 and 30, I could break that up as 5 and 6, I could break this up as 2 and 3. Notice that I have a pair of 2's that would come out. So this would be wrote as 2 square root of, I have 5 and 3 left underneath there, so 15. And then I still have my 3 square roots of 10. So after you get done multiplying, you always have to check, is my answer simplified? So in this case it was not, because 60 could be broke down. And then I check to see if these are the same radicals to add, but they are not, so I know that that's as far as I could take that expression. Okay, let's have you skip over this first part here and come down to letter A in the got it question and have you use the distributive property. So in this problem, you should be multiplying square root of 2 times square root of 6, which is square root of 12. And you should be multiplying square root of 2 times 5, which I would not be able to combine, so I would write it as 5 square roots of 2, because the 5 doesn't have a radical. Then I would check if it's simplified. 2 cannot be broke down because 2 and 1 has no pairs. 12 could be broke down, so I broke it down as 2 and 6. 6 broke as 2 and 3, and so then I had a pair of 2's. So then my answer would be 2 square root of 3 for that square root of 12 part, and then the 5 square roots of 2. These don't have the same radicals, so I would not be able to add those. Okay, the second part of this multiplication lesson is, what if I have an expression times another expression? What would I be able to do? Well, think again when I had something like x minus 2 and x plus 2. Remember that we could multiply those using 3 different ways, and I'm going to show you all 3 ways so that you are familiar. So one way is that we used FOIL. So when you had a binomial times a binomial, a lot of you used FOIL to multiply them. So if this was you, pay attention. So if I used FOIL, remember that's firsts, outsides, insides, last. So my first in this case would be square root of 6 times square root of 6. I can multiply those and get square root of 36. Then I'd multiply the outsides, square root of 6 and square root of 3. I can multiply that and get square root of 18. The insides would be 2 square root of 3 times square root of 6. I could only multiply the radical number, so I would leave the 2 alone, and I would have negative 2 square root of 18. And then for my lasts, I would have negative 2 square root of 3 times square root of 3, which would be the negative 2 square root of 9. Then I write them all out. So I just write it in one big expression, and then I start simplifying. Square root of 36 is a nice whole number of just 6. These two aren't going to change for the time being. Square root of 9 is a nice whole number of just 3. Since it's a nice whole number of just 3, then I can go ahead and multiply that with my other whole number and get 6 here. So then I can combine this whole number because it has no radical and this whole number because it has no radical. So 6 minus 6 is 0, so that's why I did not write it down here. Then I noticed that this square root of 18 and this square root of 18 are the same thing. So I can combine the whole numbers that are in front there. So even though there's no number here, I could write this 1 and do 1 minus 2 and get negative 1 square root of 18. Now, last step, is the square root of 18 simplified? No, I can break it up as 2 and 9. 9 breaks up as 3 and 3. That pair of 3's come out, the 2 stays underneath, and then I still had the negative 1 out in front, so that gets tacked on at the end. So then I have negative 3 square root of 2 that came from this giant problem from the beginning. So I know there's a lot of steps in there, but you have to make sure you run through them correctly. So run through FOIL, put them in one expression, then start looking at what you can combine or simplify. So I knew that 9 and 36 are perfect squares, which is why those broke down, and then I combined them because they were both whole numbers. Then I saw I had like terms with those square root of 18, so I combined those, and then I simplified. Now there are a lot of different patterns that you could go, so if you switch the order up in there, it's no problem, you can still get the same answer. Now maybe you were not a person who liked to do the FOIL and instead you wrote the table, and I know there were a couple of people that did do the table, so you can still do the same thing. So make your grid, and then in the top one you're going to break up that first expression, so square root of 6 and negative 2 square root of 3. And then on that left column, break up the other expression, so positive square root of 6 and positive square root of 3. Then just multiply across like you normally did. So notice I end up getting the same thing, square root of 36, negative 2 square roots of 18, square root of 18, negative 2 square roots of 9. And then you would still run through the same process that I explained over here. I think there were also one or two of you that did the distributive property, which again you can do. So if you were one of those people, remember we did square root of 6 times the first, square root of 6 times the last. So we did that product and wrote it down. And then we came back and multiplied by this one. So then I do negative 2 square roots of 3 times square root of 6, and then times square root of 3. So you still should end up with the same 4 terms, regardless of what method you decide to do. Okay. Let's see if you can try one. I'm going to get you started though on letter B. So on letter B in the got it question, you have the square root of 11 minus 2 quantity squared. Just as a reminder, that quantity squared, we expanded out. That just means you have 2 of those. So first write these 2 down, and then I want you to pause the video and actually try and multiply. So either FOIL, use a table, or distributive property, that's up to you. Just see if you can come up with the right answer. Okay. So after you tried it, these should be your 4 terms that you came up with. Square root of 121, negative 2 square root of 11, negative 2 square root of 11, and positive 4. Now then, I need to do some simplifying. So 121 is a perfect square, so that can become just 11. Then I have negative 2 and negative 2 that I'm going to combine because they both have a square root of 11, so this becomes negative 4 square root of 11. Then I also see I have whole numbers here with no radicals, so I'm also going to combine those. So my final answer should be 15 minus 4 square roots of 11. Okay, we're going to run through one more problem here, and then you can start on your assignment. So on this last problem, it's just one of those that are similar to the top, so I just want to run through one of those just to make sure you have this down. So I went ahead and FOILed this out. So my first gave me 4 square root of 18. My outsides gave me 3 square roots of 36, my insides gave me negative 8 square root of 9, and my last gave me negative 6 square root of 18. Notice what happens here. You have a couple that are perfect squares, and I have a couple that are square root of 18. You can condense this, combine them, and then go ahead and simplify. Or you can simplify first and then combine them. It is totally up to you. So I went ahead and simplified everything first. So 18 became 2 and 9, 9 became 3 and 3, so that pair of 3's came out with this 2 staying in there. And then I still had the 4. So for 4 square roots of 18, that actually simplifies to 12 square roots of 2. Okay? The square root of 36 is a nice perfect square, so that just becomes 6 as a whole number. So then I'm going to multiply this 3 with that 6 and get 18. Same thing here, 9 is a perfect square, so square root of 9 is 3. So that 3 just came down. I still have the negative 8 that I multiply together, and so that becomes negative 24. 18 we just said breaks up, so I did 2 and 9, 3 and 3. So this pair of 3 came out. This 2 gets to stay under the radical, and then the negative 6 has to stay out there to multiply with. So I ended up getting negative 18 with the square root of 2. Now, if I simplified, I can look to see what I can combine. So notice that I have 2 of these that have square roots of 2's, so I could do 12 minus 18, which is negative 6 square roots of 2, and then I can combine these whole numbers, so the 18 and negative 24, that can combine to negative 6. So again, you can simplify first, or you can try and combine like terms and then simplify after. Just, it's up to you, whichever preference you have.